Hello, everyone. Good morning, afternoon, or evening, depending on where you are in the world. My name is Anna, and I will be your host and moderator for the day. For those of you who wish to use closed captioning, you can turn it on via the closed captioning panel at the bottom of your screen. On behalf of JA Solar and PV Time, I'd like to thank you for attending and supporting today's webinar titled Next-Gen Solar Modules and Their Impact on Levelized Cost of Electricity. Last year, despite the COVID-19 pandemic, the world's renewable energy industry grew at its fastest pace since 1999, according to the International Energy Agency. Overall renewable generation capacity grew by 261 gigawatts, a near 50% rise compared to the previous year. Solar energy continued to dominate renewable capacity expansion, accounting for approximately 49% of all renewable additions. Installation of new renewables are increasingly costing less than the cheapest fossil fuels due to technological advancements and economies of scale, bringing down the levelized cost of electricity. With technological innovation as its development foundation, JA Solar has further improved its research and development investment since the beginning of 2020. By applying multiple technologies, including M10 wafer technology, Persium Plus technology, multi-busbar and half-cell technology, etc., JA Solar has made true on its pledge and launched its mass-produced Deep Blue 3.0 high-efficiency and high-power PV module capable of reaching up to 590 watts in module power, offering customers a solution with lower LCOE. Before we begin, JA Solar Senior Vice President and member of the board, Dr. Ximing Huang, has sent an opening address.
Good afternoon, everyone. My name is Ximing Huang, and I'm responsible for JA Solar's global commercial activities. It's a great pleasure to have all of you joining this webinar. As the COVID-19 continues to impact our communities around the world, we hope that you and your families are staying healthy. Amid the rise of COVID cases, we have witnessed the challenges that the pandemic has brought to our employees, customers, and communities. Despite the challenges, the PV market remains highly resilient and continues to grow. According to the latest 2021 installation outlook from the third-party institutions, the global installed solar capacity is expected to reach 176 gigawatts this year. Developing strategic relationships with customers is an important part of JA Solar's sales strategy. Many of you are our strategic customers and have played a key role in promoting the development of the PV market regionally and globally. It's our great honor to work with you to participate in the development of the PV industry, as solar energy has become a greater source of global energy generation. Over the years, JA Solar has gained significant recognition in various markets, including Europe, US, Japan, China, India, and Australia. JA Solar has also participated in the development of emerging PV market of Middle East, Southeast Asia, East Asia, and Latin America. We look forward to focusing on the development and application of solar energy in additional geographies efficiently and economically. As a global leader in PV product manufacturing, JA Solar is committed to providing PV products with cutting-edge technologies and high-level services to its customers. Throughout the years, the company is well recognized in the industry for its high-performance products. The company has won a number of top awards from third-party institutions, including the Top Brand PV Modules by EUPD, top performer by PV yield and overall high achiever by RETC. Moreover, it has focused on reducing carbon emissions in the manufacturing and managing process. So far, JA Solar has received the carbon footprint certification in France and is a member of the United Nations Global Compact, Global Alliance for Sustainable Energy, Photovoltaic Professional Committee of China Green Supply Chain Alliance, China Business Climate Action. Our mission is to maintain our leadership in supplying and servicing in the global PV market, while focusing on innovation and further enhancement in our product portfolio. At JA Solar, we continue to focus on promoting the development and application of advanced technologies in PV product manufacturing. To promote the standardization and healthy development of PV industry, we have joined forces with other solar manufacturers to advocate the standardization of wafer size and module size. As a result of all your continued support, JA Solar has cumulatively shipped 73 gigawatt PV modules to the global market by the second quarter of 2021, and is once again recognized as one of the top 3 PV manufacturers in the global module shipment ranking. To conclude, I just want to say to all of you, our valued partners and customers, we couldn't have achieved all of this without your support. Thank you for your trust and making JA Solar your business partner. Let's work together to further promote the development and the deployment of solar energy, achieve the goal of carbon neutrality, and improve the environment for all people. Thank you again for attending today's event, and please enjoy the webinar.
Thank you, Dr. Huang. Before we move on to the presentation portion of today's webinar, please leave your questions in the Q&A section at the bottom as we go, and our experts will answer as many as possible during the Q&A period. Our first guest speaker, Mr. Kun Tang, will be informing us on why JA Solar's Deep Blue 3.0 is the premium solution for providing the best LCOE. Mr. Tang has more than 10 years of experience in the development of high-efficiency solar cells. He has led and participated in various high-efficiency solar cell research and development projects, and has made significant contributions to boosting JA's technology, increasing the efficiency of mass-produced solar cells to more than 23%, reaching an industry-leading level. Mr. Tang, welcome.
Hello, Anna. Thank you. Hello, everyone. This is Kun from JA Solar's Product and Technology Department. And today I would like to give you a representation of JA Solar's products in terms of the technical future and perspective. Here, 3 parts will be involved: cell technology and prospect, module encapsulation, as well as the module yield performance test and LCOE analysis. So first, cell technology. Well, according to the latest NREL's best research cell chart, cell efficiency results are provided here within families of various technologies, including crystalline silicon cells, which now reaches a best efficiency of 26.1%. And here, those inspiring achievements made in the past few decades demonstrate in theory the feasibility of leading to the prosperity of PV industry for now and for the future. However, what shows here in the chart is clearly not enough for the real side of fabs. So by looking at the real data from JA Solar's mass production line, from the last decade, we can still experience this uphill struggle of raising efficiency of different kinds of cells. So back to 2010, the mono single crystalline cell has efficiency of only 17.5%. And now the state-of-art cell based on M10 and the Prism technology is already 23.3%. And then let's have a look at the next generation cell technology. Here we have 4 types of cells shown here. First, PERC cells. It's now approaching its top limit of efficiency, and will still be the mainstream cell product in the next 4 to 5 years, as its non-silicon cost will still be relatively lower. And the second choice is N-type cell technology. Here we have Bisium and AGT cells. Bisium cells is actually based on the TOPCon technology with a series of self-developed N-type cell technology, of which the efficiency has already reached 24%. And with the efficiency increasement and cost reduction, they are now expected to be gradually deployed into the mass production stage within the next 2 to 3 years. The third one is IBC cells. It's still on the table in the next stage of cell development for its high potential efficiency. For sure, we need to find out the right way to reduce the process of the steps of processes, and combined with other technologies such as Bisium and AGT cells, so the final cost provided can be acceptable. The fourth one is perovskite and the tandem cells. They have made significant progress, and the next 5 to 10 years, efficiency of tandem cells and crystalline silicon tandem cells are expected to approach to 29%. And then the second part is module encapsulation technology. But during the last decade, the cell and the module manufacturers have succeeded in increasing the efficiency of solar cells and boosting the output power of modules. Well, since 2018, the power of modules has been increasing much faster. And in 2019, the power is only about 445 watts. And by the end of this year, the 590 watt modules will be put into the mass production. And I think they will become widely available in the global market. Now let's take a look at the BOS cost as a module power increases. And if we take the module efficiency, the same value, larger module with higher power output will significantly reduce the BOS cost. And for example, module power from 415 watt to 540 watt, and the variable BOS will reduce about 25%. And however, the trend of the BOS reduction effect become less when keep enlarging the wafer size, and there's almost no benefit if the power up to 600 watt. And that's one of the reasons why we still stick with 182 millimeter wafer. And since no apparent BOS saving on the system side with increasing power up to an extra high level, we need to pay more attention to the risks that large modules can bring to us, such as a reliability failure, difficulty in transportation and installation, rack bearing ability. So a proper size of module must be carefully dealt with. And as we all know, Deep Blue 3.0 has already been released in the last year and become the mainstream product in the market. And we JA Solar provide customers with excellent and reliable products with sufficient capacity. And so here, 6 key technologies are applied on Deep Blue 3.0, which are Prism plus cell technology for higher cell efficiency, the upgraded M10 wafer for higher power and cost reduction, gallium doped wafer for less LID. Here, 11 multi-bus bar technology and half-cut cell technology for less resistive loss. And then the excellent encapsulation material for higher reliability. And we also noticed that high density module is one of the ways to make more benefit to our customers. So a new cell interconnection technology, so-called GFI technology, has been developed to realize it. And the GFI is short for gapless flexible interconnection. And here round ribbon together with special cushion are applied to this kind of a technology to realize gapless connection between cells. And in this way, micro cracks are eliminated totally, and higher module reliability are achievable. And this kind of technology is totally compatible with monofacial and bifacial modules, and now is optional in the product series of Deep Blue 3.0. So we believe Deep Blue 3.0 is going to play a leading role in the next few years, and the power can be as high as more than 550 watt, which brings down BOS and LCOE significantly compared to the former products when it comes to the utility scale project. Also, we noticed that now the whole industry supply chain has been established based on this M10 wafers. And here we have 72 cells patent module as our core products, and even 78 cells module will be available in the next few months, and we're bring the power up to near 600 watt. And we also have Deep Blue 3.0 Pro as one of our high-end products, which can push the power of 72 cells module up to 565 watt and the efficiency up to 21.7%. And if you look at the 78 cells module, then it will be higher than 600 watt. And the GFI technology, which is mentioned above, will be introduced to this Deep Blue 3.0 Pro, and it will combine the properties of high power and high efficiency together. And meanwhile, it also provides excellent aesthetic appearance. So that's a product we will focus on the next few years and consider to be the replacement of Deep Blue 3.0. And the third part, module year performance test. So here, in order to study and to verify the power generation and operating temperature performance of different kinds of modules, JA Solar and TV Note launched a 1-year energy yield field test at CPVT, National Photovoltaic Experimental Base in Yinchuan. And now the half-year data is available, and the relevant data is shown here. So first, the environment. The field test project is located in Yinchuan, which is typical of a temperate continental climate with an arid environment. And Yinchuan is one of the regions in China with the highest solar radiation and a solar spectrum very close to the standard AM 1.5. And the field test plant is equipped with a set of Deep Blue 3.0 monofacial modules and a set of monofacial modules with super large current. And that is module short circuit higher than 18 ampere. Well, each set is also equipped with an installed power of approximate 7 kilowatt and an inverter of 20 kilowatt. A fixed support structure is adopted for module installation about 1 meter above the ground. And to eliminate the effect of inverters, only data from the DC meter is used for the analysis. Here, the energy yield performance of Deep Blue 3.0 and the super large current modules between February and August this year is shown here. And by checking the average daily energy yield of these two kinds of modules, Deep Blue 3.0 is suppressing the super large current module by about 2%. And we can also see that when the iteration intensity increases, like in sunny days, especially from May to July, the energy yield of Deep Blue 3.0 is about 2.5% higher than those with super large current module. And in order to understand the reason why those two kinds of modules, which are both based on half-cut, P-type, PERC, mono solar cells, have different performance of electricity generation, we extracted the operating temperature data and the corresponding radiation intensity of these two kinds of modules. Here we have the average operating temperature data on 4th March and 4th May, for example. It is clear that the average operating temperature of Deep Blue 3.0 is 1.7 degrees lower than that of a super large current module. And the maximum temperature differences can be 4 to 5 degrees. And the reason for temperature differences is clear. Where the super large module employs a 12 busbar design, while the Deep Blue 3.0 modules use an optimized 11 busbar design. And theoretically, the internal resistance loss of Deep Blue 3.0 is relatively lower. And we know that active operating current of a module will cause a significant increase in heat loss on the surface of metal contact of the cell, the soldering zoom or the bus bars. And the increase in heat loss will lead to a rise in operating temperature. And this has also been verified by various operating temperature data of half and full modules, which I have just briefly introduced in part 2. And this helps us to understand why there's an advantage of Deep Blue 3.0 in power generation, which is actually due to the widening gap in operating temperature between those two kinds of modules. So based on the electricity generation data from the field and the BOS from the second part, we can easily deduce the LCOE by combining those two data together. Well, in this graph, 4 modules are demonstrated here. 2 kinds of Deep Blue 3.0 products with 72 and 78 cells. 2 kinds of super large current products with 55 and 60 cells. And it's obvious that Deep Blue 3.0 has the best LCOE thanks to the excellent electricity generation performance. And here, guided by the core value of customer first, JA Solar has always focused on technical innovation and is committed to provide efficient and reliable PV products for global customers. And in the future, no matter how the products upgraded, JA Solar's product advantage will always be the same: high power, high efficiency, excellent reliability, and a wide range of innovative products to meet our customers' needs. And I believe we will continue to focus on the product innovation and provide clean energy to everyone. And that's all for today's representation. And thank you all for listening. Hi, Anna.
Thank you, Mr. Tang. Our next guest speaker is Key Account Solution Manager from SunGrow, Mr. Jay Hu. Mr. Hu has been working in the new energy industry for more than 7 years. As a solution professional, Jay has a strong technical background and is familiar with the development trends of wind, solar, and new energy storage. Hello, Mr. Hu. Nice of you to join us.
Thank you, Anna. Yeah, good afternoon. Thank you, all friends and partners for attending this live webinar. This is Jay Hu from Sun Group. And I'm great honor to be here to share my ideas with you about inverters with innovative system, match the ultra higher power modules. I would like to give a brief introduction of today's discussion. The introduction will cover three sections. In the first part, I will talk about innovation trend of PV module, including the ultra higher power modules benefit for the PV system. In the second part, I will introduce the innovation trend of the PV inverter, including the key of the next generation inverters design. And the third part, based on the technical innovation for different systems, and some group will give the new solution. For the first part, the innovation trend of the PV module, with the development of PV system, many PV vendors keep going to release their large modules. So we compared the BOS cost of the PV system for different modules and found that the large module can reduce the system cost. We compared with the 355 watt and the overall system without the combined box cost of the 455 watt can be saved by 1.6 cents per watt. And the ultra higher power module, it means higher voltage and higher current. For the higher voltage, it means a short string and benefit for the irregular plant and less cable routes. For the higher current, it means the longer string, less strings, and higher cable routes. Well, some groups new products could adapt these two types. I will talk about that later. Why 500 watt plus PV module benefit for the PV system? We simply compared with 182 and 210 modules, analyze the BOS cost and cable loss respectively. The lower systems cost benefit from the higher current module, and the lower DC cable lose benefit from the higher voltage module. So for this result, we should consider the total PV system and need to do the balance between the cost and efficiency and the local conditions. The third part, innovation trend for the PV vendors. As the PV module evolve, inverters are constantly updated. As you know, more and more PV plants were installed. The system cost will be lower, and the great requirements for these PV plants are becoming increasingly strict. As a simple summary, the two key points for system innovation. From the DC side, we should pay more attention on the lower LCOE, and from the AC side, we should pay more attention on the grid support and compatible with the ESS solution for the reliable power connection. From these two graphs, we think that the lower LCOE and adaptability to support are the technology innovation trending. So the question is that from the inverter side, develop the new technology to match the higher power modules. We think the inverters need to have the following four characteristics in the future. The first one is higher yield, can repair component function to improve the efficiency. And the second part is the low cost. It should be integration and compatibility with the values tracking system and have the energy storage interface. The third point is safety and efficiency to improve the operation and maintenance efficiency, and also to reduce the costs. The last one is great support. Have the capable of the stable operation under the weak power grid structure. So, well, how to respond to the new situation and requirement? The first one is lower power price. We know that the typical FIT in Middle East are usually less than 1 US cent per kilowatt hour from last year. And it's also the target for the other markets. The lower unit revenue will finally lead to demand for higher yield and higher compatibility for other equipment, such as ES system and the application flexibility for different sense. The second one is a large capacity. With a gigawatt single project, we can't evaluate the operation cost as usual. The ultra-large project requires extreme convenience for the OEM work. Operator need to solve the more problem for fault currents and spare parts and the maintenance work. The third part is Sungrow system solution. Well, facing these challenges, Sungrow has been advocating the concept of the scientific design according to the local conditions. It is advocating to choose the inverter type reasonable according to the PV plant scale, terrain, and other factors. So to ensure the maximum value of PV plants in the whole cycle life. So now we will provide the central inverter solution on the flat plants such as SG 3.25 megawatt or the new product. We suggest to string the inverter like the new product 3G 355HX. Sungrow provides the modular inverter solution as 1+X. What's the module? Here we defined the modularization in 3 aspects. The first is the inverter's modularization. One product consists of the X sets of the 1.1 megawatt unit in parallel with the X range from 1 to 8 units. And the third one is the system modularization. The product compatible for the higher DC-AC ratio and the ESS extension. The third one is the component modularization. The plug and play to minimize the maintenance work requirement. So the product shows some similarity with the central inverter, but we don't think it's a unique type. It's just a module. The inverter can be integrated with the MV transformer, just like our 3.125 product. The module system also share the similar configuration with the traditional central inverter and comprises the smart combine box, smart communication unit, and the monitoring system. It can adapt 182 and 210 modules, and also compatible with the bifacial panel. And the system can support 56 import maximum, and the DC-AC ratio can up to the 2 times. For the string inverters, the SG355HX it can upgrade for the 3 points. It's a low LCOE and more safety and stronger grid support. Well, so let's us have the overall of the SG355 HX system solution. From the drawing, we can see the SunGroup solution involved inverter, emitter station, and data logo system, even local the remote SCADA, and the power plant control ability. SG355HX used 2 strings per MBBT. And what's more, when open platform with the tracking system will help increase the yield more than 1%. With the MPLC communication, we don't have to lay out and maintain the 485 cable. It can up to 8.96 megawatt per design. Also, we can help to save the PV system cost. As SG355HX could be also compatible with 182 and 210 panel. Special for the 210, the maximum capacity ratio can support 1.8 times. It can also support 12 MPBTs for 20 ampere string. For example, 100 megawatt project, we also can be used 3,744 MPBTS. With the liberalization of standards, the volume ratio is getting higher and higher. The number of the inputs of the new inventors is also increases. And the large capacity ratio design could reduce the system cost and make the power generation curve smoother. So the SunGroup's global total installed capacity exceed over 182 gigawatt, covering more than 115 countries and regions. Mainly distributed in China, APEC, Europe, North America, South Asia, and other countries and regions. And we have equipped with more than 200 service outlets. At last, I will like to share that SunGroup has been ranked as the world's most bankable inventors brand for 3 consecutive years by BNEF's Inventors Bankability Survey result 2021, and the #1 supplier in financed project. Well, that's the end of my share for today. Thank you so much for listening to my speech.
Thank you for your presentation, Mr. Hu. Our next segment will be presented by Director Technical Product Manager at Next Tracker, Mr. Eric Kuo. Mr. Kuo has over 20 years of experience in renewable energy, overseeing strategic sourcing, business development, and supply chain management in top-tier solar cell manufacturers. Welcome, Mr. Kuo. The stage is yours.
Thank you, Anna. Ladies and gentlemen, good morning, good afternoon, and good evening over the world. It's a pleasure to be invited by JA Solar to share NetTracker's large format module tracker solutions. So I will start with our company overview. So NetTracker has been ranked as the #1 global market share leader in solar tracking. We have over 50 gigawatt of solar tracker systems in deployment and under construction since 2015. And NetTracker is also a subsidiary of Fortune 500 company Flex with a very solid balance sheet. Our global presence are over 5 continents and with 8 global offices and with the staff of nearly 500. And our vision is to deliver a clean and affordable power to all. And our mission is to be the leading energy solution company. And this is the some highlights of our why Networkers is ranked the first. So we has lead the industry in features and capabilities that increase the performance by reducing the cost for customers and the owners. Here I want to highlight some our key features. Firstly is the independent role balance trackers. So it's a decentralized architecture with no hard links between the roles. So this will allow each role to be commissioned in advance of site power and simplifies the operational maintenance. And the other one is our unique SPC design with the independent smart panel. So unlike the AC powered tracker system, Nettrackers single access trackers, we are entirely self-powered. As a result, so there are no AC power surges or peak demand charges associated with moving all the trackers in large solar farms simultaneously. And also we have some software features that I will dive into more discussions later. The advanced monitoring control and the commissioning software that we will have the speed time to market, increase energy yield, and enhance performance. This is our product portfolio. One is of course the tracker, and the other one is the software and the control. So to start, it's our one in portrait called Horizon, and our two in portrait product called Nest Gemini. Our Nest Horizon is the most popular tracker in the world with over 50 gigawatt deployment tracker record. And the two in portrait Gemini is the optimal solution for extreme hard soil and the highly constrained site layouts. So both products, they are complementary to each other. And also we have the software True Capture and the Nest Navigator. We have it's the smart software and the control platforms for customers to improve monitoring precision and increase the energy yield. And moving on is the large format modules. So here to recap, so this is the evolution of large format modules. So I think to start that we see back to 2015, we only have like a small form factor modules with the cell size at 156, and it's only in multi-cell with very low efficiency. And then I think from around 2018, we have start to have a monoperk, and also we have some intermediate products using the 161 and the 163 millimeter wafer size of modules, and then is the, I think it is still the mainstream product in the market is the M6 or 160 modules with the power rating around 250 watt. And where we are right now is the, of course, this the large format and high power modules. So like JA Solar's Deep Blue 3.0 with the 182 wafer size and with 72 and 78 form factors, which can boost the power ratings per module. Okay, so here's some implication and the challenges for tracking system to implement large format modules. So we take the JA Solar's Deep Blue 3.0 for example, with the size becoming bigger, and also the weight getting higher. So actually you will have more challenges to implement the trackers. Like we need more torque on the drive system, and we need stronger module rails. And also you will the module itself will suffer the higher static and dynamic wind loads, and also increase the weight will also need more hardware support, and of course higher install time per module. And our innovative and data-driven single-axis trackers are uniquely positioned to ensure installation, quality, and reliability, regardless of module size and the weight. And then let's speak something about the wind. So wind is the determining factors for tracker design. So actually, you have to keep the tracker operate functioning over the design product life cycle without any damages. So actually, most of the in-field tracker failures, they are the result of shortcomings in wind engineering analysis. So that's the reason why the wind tunnel test must be conducted and to verify the parameters in order to implement large format modules. And then there's also one very key factors how to make a stable and reliable tracker with these 182 millimeter modules. It's that you need to study hardly on the dynamic effects. So most of the trackers, when you consider the wind load, actually they does not scale linearly. So wind load scale accordingly to the square of the wind speed. For example, some trackers like our 2in portrait tracker designs, actually they have twice the core length than the 1P portrait. However, the wind loads are actually over 400% larger. So these wind load effects are amplified under the dynamic loadings. Okay, so and then this is the also in parallel that we need to validate the PV module can work functionally. So besides the multiple wind factors that we need to take into consideration for making a reliable tracker, actually compatibility is also one of the primary factors to consider a good tracker design. And the Nextracker and the JA Solar actually together we conducted form fit function and installation check proactively prior to the product launch. And also in parallel, actually we will run the mechanical load tests and based on both the IEC standard and specific site requirement. And since oftentimes that we will have projects with higher loading requirement. So after all these are done, we will issue the compatibility approval letter signed off by both JA Solar and Nextracker to ensure compatibility and reliability for both mutual products to our customers. Okay, and then this is the how we define a good system level success to implement large format modules. So one is of course the we need to study on the design test level to a full range. Firstly, of course, you have to study the frame design of the modules and also the attachments and also the FE analysis to check the deflection and deformation of the modules in advance. And I think I like to address more on the attachment. So actually, there are different mounting methods from different tracker companies. I think some tracker companies actually they use clamps and some use bolts and nuts. And actually, we Nextracker use a very unique bobtail design. This can to prevent the fastener losing and high cycle fatigue. Actually, we use the lock bolts rather than conventional nuts and bolts. So, and by doing this, gives us an edge to be the leading tracker system to sustain challenging sites with high pressure low conditions. Okay, so this is what we consider the mounting solutions for that to implement large format modules. So you see, when you have a very good quality and reliable modules, such as JA Solar's Deep Blue 3.0, so actually you only need a line mounting or over 90% of the site. And during the very extreme zones with higher pressure values, it's like you will also need some medium mounting. And however, if you use the weak modules, actually you need to add more supports, more planes and reinforcement to make sure the whole site can work functionally. So actually, a weak module will have some cost penalty to the asset owner. Okay, so and this is the large format module impact on LCOE. So actually, so we will see that the more power per trigger roll based on implementation of the large format module. And also we see more power per total area. Take I would say mainstream M6 modules, for example, to compare with the JA Solar's leading Deep Blue 3.0 modules into consideration, you can see the panel size increase. And by doing that, you can see for per trigger roll, you can see every trigger roll here we use semi-3-string design, and you see per trigger roll actually for Deep Blue we only need to put 78 pieces of modules, and we can get much more power. We can get 46.4 kilowatt against only less than 40 kilowatt than M6 modules. So by doing this, so you can see more power per trigger, and we can have a significant labor reduction, and also we have some here reduction, and also you will only need a less total wiring and the land area for large when you use the large format module for the low configuration. Okay, this is okay. So this is our unique software called Next Navigator. This just shows how we mitigate the extreme weather. So as you can see from here, most severe weather actually they came from the snow and the storm, hurricane, and the hail. So our unique Navigator actually we offers a greater solution for extreme weather conditions. Our Nest Navigator is designed for all post-commissioning and the operational management and the monitoring. So for asset managers and the plant operators, they can use our Navigator to remotely trigger the hailstorm and the hurricane or typhoon storm or snow shed. So once a user initiate the command is given, all triggers will move to the specific defensive position within 1 minute. So and also the test conducted at IETC also show that the hailstorm feature in our Nest Navigator will increase the survivability of the PV modules from 81.6% to 99.4%. And then this is our another software called the True Capture. So how does this intelligent self-adjusting tracker work? So actually the standard system tracker, we will track all rows. I would say standard systems, they track all rows identically regardless of terrain undulation and the construction variances, and do not capture as much light as they could if the weather changes and become cloudier or even hazier. So in that case, the energy generation will dip. However, by using our True Capture, we solve both the challenges with a unique and integrated approach. So to capture continuously dispatches optimal tracking algorithm to each tracker role, and we will correct for shading on unlimited and caused by uneven ground and challenging weather conditions. And by doing that, you can get more energy yield up to 6%. Okay, and this is the white paper that we published, and it's downloadable from our website. Then you can get more clear picture on how we do the risk mitigation and how we develop our products to adapt the J Solar's Deep Blue 3.0. Okay, thank you for your attention. Thank you. That's all I have for today.
Thank you, Mr. Ko. Next, addressing global EPC contractor prospects is the VP of HDEC International, Mr. Han Zhou. Mr. Zhou has been deeply involved in the Asia-Pacific new energy market for many years and has obtained wind power and photovoltaic general contracting projects in Vietnam, Myanmar, Thailand, Malaysia, the Philippines, and Indonesia. Mr. Zhou, welcome.
Thank you. Thank you so much, ladies and gentlemen. Good day. So I'm Johan from Power China Huadong. So taking this opportunity from the JA, I would like to share some experience, particularly with JA in the world market for solar EPC project, and as well have a short introduction of our company. So my presentation will take about 10 to 15 minutes. So there are three parts. The first part is about us, who we are, and second part is, as I mentioned, I will show some typical projects with our experience, and the last part is our future collaboration. So I will start with who we are. So you can call us Power China Huadong or HDEC. I mean, we are a subsidiary company of Power China. And since more than 6 years ago, we have been built in east of China. So that's just some figures of our company for last year. And our business is quite wide because we started with hydropower business a long time ago, but actually now we are focusing a lot on renewables with strong support from the government and all the partners such as JA or Sandro. So we are becoming very active in renewable energies in the worldwide now. So you can see that though we have three major parts of our business, but now solar and wind have become very important part of our company business. So until now, we have two headquarters. One I mentioned is in Hangzhou, another one in Dubai actually, with 6 regional headquarters in the worldwide, covers most of the big and medium-sized countries, including more than 50 key countries we call. And the second part I want to go through is more about our experience. So until now, we have been involved in a lot of renewables, mostly solar and wind. And at the beginning, our company started only in China, but since about 5 years ago, we started our EPC projects in foreign countries. So until now, we are not that big, but we have completed already more than 3 giga projects in several regions such as Asia Pacific, Africa, in Middle East, and also in South America. So apart from that, we are also doing a lot of wind, so including onshore and offshore winds, both in China and abroad. So There's the one important project I really would like to share with you is called Daodian Solar Project. This project, of course, actually we have been partnered with GA together, and this project, as you can see, that it's in Vietnam. So about 500 megawatt. The project started in 2018 and finished in 2019. You can see that it took only 11 months to complete all the projects. And the project owner is a Big Green from Thailand and Sunfa from Vietnam. And the OE is from Oracle Thailand, but the Oracle is actually from Australia. So the whole project is quite multiple countries involved in. So the interesting part of this project is not only that it's big, but also from the picture you can see that it's very close to a reservoir. Actually, it's a very big reservoir in southern Vietnam. So the interesting part is that this project is flooded every year. Actually, you can see from the diagram that the green is the flooding. So every year from June, actually from July until February next year, the water comes. The water comes, and picking time is in December usually. So the flood will cover the whole project site. The picking time is about 2 to 3 meters above the ground. So you can see that it's like we call half dry, half wet. So only after February the water will go away. So the whole project is very active. You know, it's because most of the time we have to work, like including powering on water, or sometimes on dry land. So you can see that this is the sequences of the construction. So the green means the powering. The blue color means the installation of the trackers, and the red color means the installation of the PV panel. So you can see that it's not really one by one or area by area, right? It's all because of the flooding. We have to find the best every day or every couple of days. We have to predict which part of the area is the best to make more construction of powerings, because in maybe just a couple of days that area will be flooded. So so our construction methodology was very well planned, and we made very complicated predictions for the whole construction of the site. So you can see that it's because you can because the site is flooded, especially as I mentioned, 2 to 3 meters above ground sometimes. So we use very long piles. It's about the longest one is 12 meters. So on dry land, we just pile with a very classic machine, right? But on water, we have to use ship, and it was quite difficult because this project, it was a very early stage project in Vietnam, and there was no such ships or equipment to do the piling at all. So actually, we imported several the important parts from China, and made some installations in Vietnam to have this kind of ships. So otherwise, we could never finish the whole project in just within just less than 1 year. So this is very special part of the project, and you can see that that's actually when it's flooded. So we have to make sure that the panel is above the water, right? So even for the whole installation of the panels, the workers have to work on water as well. So another part of the project I want to mention is that I said that it was a very multi-known countries involved in, and as well because this project we provided very comprehensive financing solution to the owners. So the financing, 85% of the capital is from China for 2 years. So this is also a very international financing model, and we had to accept all the Western standards from Oracle and to adapt as well the Vietnamese code for the standard. Because a lot of people may ask what's the important part of EPC for solar project in the worldwide? What's the key? Actually, I think the technical part of the solar project is not that complicated as hydropower or solar or turbo power we did in the worldwide, right? But solar is more technically simple. But I have to mention that the key, in my opinion, the key to have a good EPC project for solar is one of the most important parts is that you have to do very fast. I mean, it includes you need to have fast reaction. You need to do very fast team building. You have to know very fast the standard of the local like connection works or grid. You have to know how the people work there, because a lot of countries, they have solar, it's very new, right? There was no records at all. So you have to do a lot of preparations very fast before you start, but you only have like half year or 1 year to complete. That's the most challenging part of being actually a solar EPC company. So that's just a very simple thinking. And also to be mentioned, you know, Thai owner usually is very strict that they're totally happy about the panels we provided, which the majority of the panels are from JA. So with JA, actually we have a lot more projects, more than 1 gigawatt until now. So another one is in Ukraine, and this one you can see that 70 megawatt we just finished within 6 months for the solar park. So the owner is also quite international owner, First Energy. So another interesting part of the solar is we did a lot of floating. So we started floating solar very early in China, and we actually had some even invention of floaters, even though now they are not very widely used, but we have done quite a lot of studies. But in Vietnam, we did another project. That's the first floating solar for us in foreign countries. So with EVN, the capacity of 46 megawatts. So and financed by the ADB. To be mentioned, another big floating we are doing now is still under construction in Indonesia. We signed a contract with Mastao and PLN this year. So this is actually much more difficult. I think until now that's the most difficult project we are undertaking for floating solar, because of water depth, and the water variation are both challenging. So our team is actually in Indonesia, even though with the COVID-19, but we still are expecting to have it completed in very near future. So apart from solar, I just have to show that we are doing also a lot of wind, onshore and offshore in the worldwide. So especially we are doing very big wind offshore solar in Vietnam. Actually, several ones. This is the biggest one we're doing with the Siemens Gamesa and the Gold Wind. So that's some experience I really would like to share with you today. So the last part is quite simple. So you can see that that's our world map with most of our renewable, actually solar and wind. You can see. So you can see that we have really a lot of projects already in all our 6 regions. Africa, like Nigeria, like in Pakistan, a lot of solar winds in Vietnam, or in the Philippines, in Malaysia. So with this all projects, we have built very strong collaboration with all partners worldwide, and everyone knows that we are now quite in winter time for solar business, but I really hope that with all us together, renewable and green are really the future. So we are also looking forward to having more collaboration with all of you in this meeting, and I believe that all us and all our partners like Jay, we are able to deliver to you a very good solar park. Thank you.
Thank you, Mr. Zhou. Our next speaker is technical expert, head of Global Competence Centers for Solar and R&D of TÜV Rheinland, Dr. Christos Monokroussos. Mr. Monokroussos specializes in the characterization of solar cells and PV modules, quality control of measurement systems, standardization progress, and PV module reliability. Christos earned his doctorate degree in photovoltaics from Loughborough University. Hello, Dr. Monokroussos.
Thank you, Ms. Chairman, for the kind introduction. I see a lot of familiar faces in the participants, and I'm very excited to talk today about quality aspects for very high power output PV modules. As you have heard from the previous participants, the larger the modules, both in power and size, would have a significant benefit in LCOE. But there are some questions related to the reliability and the quality of these modules, and this is what I will try to shed some light on. I would like to say that generally my presentation will be broad today, so I don't have the time to go into details, but if you have any questions, feel free to address them. Okay, so what I have for the outline today, I would like to first introduce to you to the historical trends for PV module sizes and also conversion efficiencies. Then I'm going to talk about more details on the influencing factors for high power PV modules on a module level, component level, field reliability and necessary standards to comply. And also what is the necessary equipment that you need in the laboratory and the factory to measure these modules, and conclude. Looking in the 70s, these pictures may appear a bit like archaeology to some people, but modules used to have an output between 5 watts up to, let's say, 90 watts, and they were maximum 1.1 meter long. These were the times that when the Jet Propulsion Labs conducted the first reliability study to find out which was the most critical failure for these modules, they identified as shooting was the #1 reliability danger, because people thought that round cells on a white background made excellent targets for shooting. Let's see what happened over the last 10 years. So when we started in 2010, most companies utilized 72 cell configuration with 5-inch cells, or 60 cell configuration with 16 cells, that was later called the M0 wafer. Slowly, most companies adapted into the 72 cell configuration with using 16 cells. This is 156 times 156 millimeter size cell. And this remained for several years. And it was not until 2017 where we had the first innovation where people actually realized that you can have some additional reduction for series resistance if we employ the half-cut twin cells configuration. And there was also an additional increase in the wafer size. They used the M3 wafer, which was slightly bigger. And this also increased a little bit the dimension of the module that brought it above 2.1 meters. In 2019, we also saw the introduction of the M6 wafer, which was 166 millimeters long, and they employed the same configuration, connecting 144 cells in series. In 2020, we saw more innovations. We have seen the 182 millimeters connected in series in 156 half-cut cells. And we also saw the M12 wafer, which is 210 millimeters long, and people connected it in 120, if I remember, half-cut cells connected. So to summarize, we haven't seen any significant change up to 2016, and after 2017, we saw innovations being introduced, which significantly increase the size of the PV modules, starting from barely 2 meters, and now we have exceeded 2.5. We've actually close to 2.6 meters long. And this is beautifully captured in this slide, which I'm showing here, which is courtesy of NREL, the National Renewable Energies Laboratory of the United States, which shows that there was a significant increase in the conversion efficiencies of cells between 1980s and now to 2000. And later on, we have made very small, marginal, but important improvements. Significantly improve the efficiency of the conversion cell, where two things was the inclusion of selective emitters and improvements in the passivation. So technologies like PERC, for example, have been introduced. And this has increased the conversion efficiency of the cells, and is also prospected to further increase in the future. Wafer size, we talked briefly. In the 1980s, we used the cyclic wafer, so cells were round up to 1980s. Then we used the pseudo square mono configuration on a 5-inch cell. Then people start moving into poly. They use a full square 6-inch cell, and it was not until the 2010s that we actually use the pseudo square 6-inch mono configurations. And later on, people start to combine them in series, and they cutting the cells. So we use the half-cut pseudo square mono configuration, and it's prospected to use more of these connected in series in the future, together with the M12, for example, wafer, right? Talking about sizes, as we said, up to 1980s, sizes were barely exceeded. Excuse me, I have a small overlap. Yes, so I cannot see the top bar on this slide. I'm going to come back to the previous full-size presentation on the next slide. It was 1 meter long up to 1980s. In 2000, up to 2000, we had like a maximum size close to 1.5 meters. In 2010, the longer module in the market was 2.2 meters. In 2015, it remained the same. In 2018, we saw with this pseudo square mono configuration in 7 to 2 cells connected in series, modules reach 2.1 meters. And now in 2020s, as we mentioned before, modules up to 2.5, 2.6 meters long. And it's prospected to further increase in the future. So potentially it can even reach up to 3 meters long. But you should take all these future projections with a grain of salt, right? So what we know for sure is what we are today. So I would also like to talk about the influencing factors of high power PV modules. So here I would like to talk about module design, component design, reliability, and process factors. There are also additional factors like packaging and transportation, system issues, and operation and maintenance. But I'm going to focus on this pitch on the first 4. So starting with module design, the influencing factors is module size, circuit design, distance between cells, and number of cells per bypass diode. A good point of view of which tests are necessary when you have significant changes in module size and solar cell size, and also solar cell output, is the retest guidelines, which are detailed in IEC technical specification 62915. So for example, when the module side exceeds 10%, you have to repeat thermal cycling, dump heat, static mechanical load, and hail test if the glass is non-tempered, and then module breakage test as well. For solar cells, you have to include that we have to test for thermal cycling, dump heat, static mechanical load if the coating of the cell is different, and hotspot test, as well as reverse current overload test and temperature test. If there is significant change in the output in terms of Pmax, IC, VOC, both of the cell and generally the module, you may have to perform thermal cycling test if there is significant change in the current which flows through the module exceeding 10%. Hotspot test will have to be repeated, and bypass diode thermal cycling test would also have to be repeated if you have more cells corresponding to the diode. Reverse current overload test would also have to be repeated. There are more things, but time does not allow to go here in great detail. What is important is to understand that the more cells and the larger cells that we have would have an effect on the performance parameters. So the larger the wafer size would correspond to a higher IC and probably Pmax, and the more cells that we connected in series would result in higher VOC and also higher Pmax. Another important factor is the effect of distance between these cells in a PV module in the encapsulation. We have heard from previous presentations that the smaller the distance between cells is often used to maximize the active area of PV module and also minimize the total PV module area. These are desired properties. However, the closer the cells that they're brought together, the more susceptible are to thermomechanical stresses. So we have novel technologies like PV tiling, shingle cells, and PV paving. So essentially, in shingle cells, each cell is positioned slightly on top of the other, and this may increase the stress that is receiving when the module is exposed to thermomechanical stresses. For PV paving modules, cells come one very close to the other, and the distance is marginal. So indeed, we have seen some failures in thermal cycling, for example. That's like the one that I'm showing you on the right, where one of the cells cracked. So the smaller the distance between cells, the more susceptible cells may be to thermomechanical stresses. Another thing we would like to talk about is the hotspot test. So basically, the higher the string power will increase the stress that the solar cell, when it's exposed to reverse bias, when it's fully shaded, which may cause serious damage such as hotspots, which may lead then to burn marks on the backsheet and the solar cell under test. So basically, when you fully shade a cell, localized temperatures will increase very much. This may result in change of phase of the EVA. So from solid to liquid, may release gases, and eventually you may see bubbles forming in the backsheet. As temperatures further increase, it is even possible that a cell will burn, as I'm showing you here on the example of the right. So these are things that the new concept would have to tackle. And we have seen good designs and bad designs. So I cannot generalize saying that all new concepts are good or all new concepts are bad, but there is definitely some thought that has to be done in the cell design, on the module design, excuse me. Another critical test is mechanical load. So large module may lead to increased stress under mechanical load. And there are a couple of things here which are very important. is the frame thickness, is the cell size, the mounting configuration, and the glass thickness as well. All these things would have an effect on how well a module behaves under mechanical load. And here I'm showing you an example here where we have clear module bending under the effect of mechanical load. I would also like to talk about, since many of these modules, these large size modules are bifacial, there is also a specific issue that bifacial modules have. When they are fully illuminated from the rear, the frame and the junction box may introduce shading on the rear. And this would be very visible on the IV curve where we see kinks that indicates that there is significant cell mismatch and their module operating in deep reverse. Of course, manufacturers now are smarter. So instead of using a large junction box, they use these small junction boxes that contain one diode each. And in this way, they're able to distribute the stables, the shading evenly into the substrings of a module. I'm going to talk about component design now. So generally speaking, the large size modules may often have increased currents, which will apply higher stresses on PV components such as cables, connectors, diodes, and junction boxes. So I would like to show you here an example. Here we see that the effect of large currents would have. On the reverse current overload test, where we have defeated any blocking diodes, we apply reverse current, which equals the maximum overcurrent rating times the safety factor of 1.35. Specifically here, the module had a 25 amp rating, resulting almost 34 amps applied in reverse to the module. This would cause a PV module voltage around 62 volts and gives rise to the module temperature up to 92 degrees. And here is the question: would a diode be able to withstand 92 degrees when it's operating at 21 volts? These are very stressful for the conditions for a diode. So large currents and voltages would increase the risk of a diode. Attention should be paid to diode selection. So as the IEC increases, we have higher reverse current, and that would increase the diode temperature. As the VOC increases, we have higher reverse voltage for its diode, and that would increase the leakage current of the diode. So diode selection is extremely important for these beasts. Talking about reliability and which standards are necessary. So large size modules should meet various application, the requirements for various application environments. For example, if you have a mild environment, I think so the 61215 and the 61730, the first ensures the quality and the second the safety of a PV module, are absolutely must. And they have shown that actually modules that comply with this standard are able to perform quite well in these environments. For bifacial modules, the newly released 61215, which was published in January this year, addresses the necessary requirements together with 2PFG. 2PFG internal standard of tooth Rhineland. 2PFG 2665. So I was saying that 2PFG is an internal standard of tooth Rhineland and also addresses safety requirements for bifacial modules. Furthermore, we have for high temperature environment, there is a new technical specification recently published, is the ICTS 6312826, which defines new test conditions actually for modules that are supposed to operate in a high temperature environment. In a mountainous environment where modules are supposed to see significant snow loads, the non-uniform snow load testing is a must, and this is detailed in IEC 62938. Furthermore, I would like to talk about our experience in from outdoor testing of PV, of high power module output PV modules, and which were also very large in size. Most of our experience is actually all of our experience is not more than 1 or 2 years long, and therefore it is very difficult to say safely whether these modules will continue operating well or not. But something which is very important, that reliability is extremely related with the encapsulation package of the module. And since we have not seen significant changes in the encapsulation package that has be used for these modules, I wouldn't expect to have a very significant impact. But time will tell. It's only time that can show us whether or not these statements are right or not. A couple of things about the process. First of all, the non-uniformity of irradiance that is used in the solar simulator. Solar simulator is the equipment that we use to flash a PV module, right? The larger the module, the more susceptible becomes to non-uniformity changes of the solar simulator. So typically class A, class A plus, class A, even class B solar simulators can correct the power of the PV module if they're calibrated correctly. At the same time, class B again and class C solar simulators may have issues predicting correctly the power of the PV module under standard test conditions. Generally, non-uniformity of irradiance would introduce kinks in the IV that would increase the uncertainty. So knowing the flasher and how to operate it and calibrate it correctly is very critical. Furthermore, you have to have an upgrade in the solar simulator to cover these needs. So I'm using here a slide which is courtesy of Spire, which they actually having a new large size solar simulator which is able to cover 2.5 meter long, 2.6 meter long PV modules. It is physically possible to do that using a smaller solar simulator because the module will not be able to fit in the illuminated area. But there are additional equipment which we also need to upgrade in order to test this module. For example, UV chamber, here is also a question between capacity and also uniformity of the UV chamber to be able to uniformly illuminate the PV module under test. The light socker that we use for stabilize the module, there is also here again a question between capacity and also the non-uniformity of irradiance that is exposed to the module. Mechanical load test, again, we have here a question between size and also the uniformity that is applied on the module. The mechanical load should apply, the static mechanical load should apply a uniform load on the test for sure. Thermal cycling, the electronic load would have to be applied. The reverse current you have to upgrade the power supply. For wet leakage, of course, the water basin has to be upgraded, and snow load, there is also here a question between uniformity and capacity. And with this, I would like to conclude. So PV module sizes have substantially increased in size recently, while the conversion efficiencies have also increased. Each new technology brings with it also new potential risks. Testing and field experience is required to prove quality and long-term reliability. Components need to be chosen suitably to fit the new specification and stresses, particularly tests which present thermomechanical stresses and introduce fatigue may be critical to assess reliability. And test equipment for factories and laboratories required an upgrade, else results may be questioned. I would like to acknowledge the contribution of my colleagues from South Rhineland, specifically Ami Guo, Eka Janknich, and Jörg Althaus for the contribution in my presentation. I'd like to thank you very much for your attention. Thank you so much.
Thank you, Dr. Monokroussos. Up next is our last speaker of the afternoon, Senior Analyst from IHS Markit, Ms. Holly Hu. Ms. Hu is responsible for tracking and analyzing solar policies and markets in Asia, particularly China and Japan. She also provides in-depth coverage of the polysilicon to photovoltaic module supply chain, with a focus on Chinese manufacturers. Welcome, Ms. Hu.
Thank you. Thank you, Anna. Let's start with our final slides today. And hello everyone. I'm Holly Hu from IHS Markets, and my topic is more focused on the global solar PV market trend. Because this afternoon we have learned a lot of from J Solar, from the module players, from the inverter and BOS player like Tracker, and also with the EPC and testing players here. And my presentation is quite focused on the solar market, especially what happened in recently and how the solar market segmentation analysis in the recent years. And before we go to the solar markets, actually, we are quite interesting on what happening in globally, why renewable, especially solar, become quite important in next futures decades. Because we are going to move into the net zero carbon emission time in globally, and also solar as the most important renewable source will play the most important role in decarbonization. So we listed the two part of table here. First one, we are summarize the key countries in the net zero carbon emission targets in recent years, and also another part is their detailed renewable energy target. From estimate of from statistics of IHS Markets recently announced, there are total 127 countries in globally. They have listed or they have announced their net carbon zero emissions in the next 30 or 40 years. And with China enter with targets in the 2020, there's a 2/3 of world largest emissions countries will join with the net carbon emission games. And another important meeting we'll hold on this month is the COP26, which will be in UK, Glasgow, and this meeting will play quite important, give us quite a lot of guidance on how next 20 or 30 years this key global countries will play in with the net zero carbon emission, and to target to control the climate change and also reduce the coal file in the next 20 or 30 years, and also how realize those targets in the next future. So it's quite important global summit happened in this month. So let's go to detail for look at that to give us more guidance how those market will platform in this way. And in this table, Germany as the leading country in the no matter on the carbon emission target, and also with the 60% of target renewable energy sources plays the leading areas in this way. Okay, then we move on. Another more interesting topic is about renewable investments in the next decade. And we comparison with different types of renewable technology in this chart, and how much they will be estimated in the assets investments in the next 10 years from 2021 to 2030. So from the globally, we saw China mainland and European is the key country and regions to have for the next 10 years of renewable investment. So that will covers like 56% of total investment, renewable investment in next 10 years. the total estimation of renewable assets investment will reach $3.2 trillion during this period. And also from the technology way, we found solar separate by the solar DG and the solar utility scale, onshore wind, offshore wind, and the storage at hydrogen will be dominant. Especially solar and wind were dominant with the renewable assets investment during this period, with average $350 billion per year will be invested in renewable sectors. So that will give us a lot of opportunities in this industry to build up the business. Okay, then we move on to detail on global solar markets. Actually, we saw the global solar have a lot of historical have a lot of story, and even in 2020 we suffered the COVID impact, but we saw the solar installation still have a positive in the annual growth rate. So that's give us quite a lot of confidence in this sectors, and that's why even under this year we also facing the challenge with supply chain price, the high supply chain price, also the longer lead time for the delivery products in the globally. We still believe like 170 gigawatts level of demand solar will be installed this year in 2021, and APAC region still be the largest areas to have the amount of solar to be installed, led by the China mainland, because China has been the largest solar installation market since 2013, and with 33% of shares in China in globally in 2021. So the other point why we are giving like 170 gigawatts level of estimation for the annual demand this year, because in the past 8 months we still saw like 60 was level of module is shipped from China to globally to other market, and we add like China demands like nearly 50 to 60 gigawatts level in 21. So we still roughly give the idea of 170 gigawatts level of demand in this year. And then we go to see some market details segmentations. Actually, we normally break down our demand by different segmentations like residential, commercial, and utility scale. And we break down them by the system size. And from the residential segment, we normally have the system below 10 kilowatt, but this segmentation always have some challenge in 21, because like mainland China, the average unit residential system is much higher than that. So that's why we saw, like generally we saw residential and the commercial side is called distribution generation, and that's cover like 40% of global demand in the next 5 years, and with 60% still around in the utility scale. So the large size of projects still dominant, have higher shares in the global demand. However, let's just give you some brief idea of the global demand, how they look like. But when we saw the detail market, it's different pictures. Actually, we break down the like 80 countries in 80 countries solar market as a different solar market, and break down their demand by their segmentations, and you will find the shares of market. I mean, different segmentation is quite different. Normally, we saw like some developing country and also the emerging solar market is there quite dominant by the utility scale. Their trading, their tender offer with the bidding process is generate much more installation of solar in the past year. And then we also found like developed country and also like European country, they are more concentrate on the DG, the distribution generation. And also we are now and giving more details, you will saw from the regional level, they also have a different market segmentations. So from APAC is quite, the share of rows segmentation is quite close with the global numbers. So you will find like nearly 60% of utility scale, and also the DG covers like nearly more than 40%. But Europe is a region which quite concentrate or have a historical efforts or the interesting on the DG market. So their DG market is quite close with more than 50%. And American with the Africa and Middle East market, they're more concentrated on large utility scale. So from this chart, you're finding different market, they will have some choice with the type of products and also with different system design and with different policy to drive this demand. And as I mentioned a little bit earlier, this year is quite special with the solar supply trend price, material price hike, and also with the higher delivery costs. So DG market become a little bit more interesting with the or more tolerance with less high price. So we're giving a little bit more color with DG analysis and brings us with top 10 DG market in the next 5 years. You will find we announced like over 450 gigawatts of DG PV will be installed in the next 5 years. And the largest market is still in China because later I will give more colors on the China DG market. And also like Australia, India, and Germany, US, they also quite have a much more shares or installations in the next few years. And then we give more color on China mainland because it's the biggest DG market and also is the have a lot of large utility scale in the market. I mean, in the early this week or last week, our president, she have announced 100 gigawatts of big base in the utility scale level of projects start already from this year, and that's give a lot of pipeline projects in our China market. And then also from the residential and CNI sector also have a lot of policy to drive this market. And in here we give some brief idea about the residential market, what happened in last 2 years, and you will find that it's quite impressive market in China. Actually, we have separate the residential budgets with different FIT level since 2019, and tier August to this year, the NEA announced like 25 gigawatts of residential solar system already installed in China, and the market is quite concentrated within the key province, like Shandong, Hebei, Henan. The 3 provinces cover more than 75% during this period. And the size of residential market also is larger than the average system size. And that's I think the basic reason is we using the full cell model because we the policy is giving the FIT level to all generation you produce in the solar system in your rooftop. And that means you will be generate more power and more getting more FIT in accordingly. So using the at least as much as possible with the rooftop size and building as large size projects is best for your projects IRR. So that's why we're compare with other market like Europe and US. They normally using the net metering method in residential market, and that's giving the size of projects has limitations. So that's why we saw the China residential market is quite different with other countries. And in the middle of picture, we're showing a quite important policy announced actually in the middle of this year, and it's called Country Rooftop DPV Pilot Program. And the government building rooftop will be targeted with at least 50% of government building rooftop will building solar system in the next few years. And also the school, hospital, the public building also have more than 40%. And even rural areas of residential system rooftop will have more than 20%. So here, August of this year, the NEA release, there's 676 counties or cities or districts that already being granted within this program. So that will be quite determinant in the next 5 years or less than 5 years of DPV market. Okay, and then we move to another big countries, solar countries is US. And in US, we also got quite good news from their DG market in last week. And in last week, the US DOE, their authority announced a new program called NSCP, is giving the target with the next 5 years to build up like 500 million house or community solars in their rooftop, and with by the solar power. So that means this market still have a quite booming, robust demand comes in the next 5 years. And also compare with the system cost in the community solar, and it's much compatible with residential and normal CMI sector. So that's why we're giving a round of more than 25 gigawatts level of total amount of commercial community solar demand coming to US. And another another rumor for the US market is their ITC extension, because after President Biden on board, and they already extension ITC for 3 years, and also recently with their targets on probably on the COP26, as I mentioned earlier, they probably will have further determinations on the solar development and putting the ITC more extension, giving ITC more extension, and that will be not only driven DG market and also with the whole US market. And also the third, also another quite important region of renewable or solar market is European. And we mentioned European market is quite concentrated or have more shares in the DG market. And we listed like top 5 countries in the middle commercial market in Europe is Germany, Netherlands, France, Italy, and Poland. But European, they have a different solar radiation, and you are finding the solar LCOE level with their electricity price is quite different within this top 5 countries. And like Germany, they have a quite higher electricity price, so they're more driven to their self-consumption ratio, because the cost of solar become lower than before, and the electricity price is become higher, and that making you more generate or installed the renewables in your rooftop. And also recently, not only China will facing the limitations of electricity, and European country also have the some lack of electricity in their industry level and also the residential segments. So they also have a higher electricity pricing recently. And I heard my boss in the Spain, they have actually raising up 3 times of electricity price for their peak time usage of electricity, and that will be making more demands for the renewables. And we also mentioned in the early slides, and like European, like Germany, German market, they are quite focused, or they have pioneered in the renewable sectors, and they have early targets to reach the net zero carbon emissions, and with higher renewable target. So for Rose market is quite give us a lot of opportunities in this solar demand. Okay. That's finished my presentation today, and back to you, Anne.
Thank you, Ms. Hu, for your analysis. That brings the presentation portion of our webinar to a close. Thank you. A recording of today's presentations will be posted for reference. We'll now begin our Q&A segment. Thank you for your questions. So we're going to begin with a question for JA Solar. The question is, what's the development trend of future PV modules, and what can JA Solar bring us?
Well, I think, just as I mentioned in the representation, high power and high efficiency will always be the key factors that we need to focus on during the future PV module development. And well, this, of course, this must be based on the reliability of module performance. And for high power, first, although it might be the fast way to improve the power within a very short time by increasing the wafer size or module size up to an extra large size, then we were not rushing to super large size module, which, as I said in I said, in this stage, it might lead to unexpected risks in terms of the module reliability, where during the installation or maintenance. So I think we still need to focus on the development of cells and try hard to raise both P-type and N-type cell efficiency. Well, I think the cell efficiency is and always will be the key factors influence our module performance. And well, second, for the high efficiency, we, as I said, we have GFI technology, which combine the high power and high efficiency together. So I think it could be one of the direction that might change the thought when we develop the module in the future.
Thank you. Thank you, Mr. Tang.
Yeah.
Thank you.
You're welcome.
So we have another one. This question is for SunGrow. And the question is, what is the future for PV inverters, and what does SunGrow bring to this space?
We think that the higher yield, lower LCOE, and safety efficiency and adaptability to support the technology innovation training for the PV inverter. SunGrow has been advocating the concept of the scientific design according to the local conditions. So it is advocating to choose inverter types reasonable according to the PV plant scale, terrain, and other factors. So to ensure the maximum value of the PV plants in the whole cycle life. Yeah.
Well, thank you. So next question for Next Tracker. Does Next Tracker expect larger modules to be standardized in the future with the size to be followed by the entire industry?
Thank you, Anna, for the question. So actually, we in Next Tracker, we think that most tier one module suppliers, they are already aware of the importance of standardization for the benefit of supply chain and the EPC and the asset owners. So especially for the utility scale project, the advantage of adopting large format modules, of course, in this case, is the 182 millimeter modules are very significant and obvious, since it brings down the BOS cost and improves the LCOE. So we think besides China, we expect to see more projects online with these large format modules in non-China regions once the recent supply chain constraints are relieved. Of course, I'm referring to the power rationing in China and also the logistic increase. Yeah, thank you.
Thank you. Now, next question for IHS Markit. What's mainland China's DG market going to be like in the next few years?
Yeah, as I mentioned in the slides, actually, DG market have quite positive news with government release their the country pilot DG rooftop plan, and we believe in the next 2 or 3 years the rooftop market will bring more than 100 gigawatts level of demand in the next few years. Thank you.
Thank you, Ms. Hu. We have another one. This time for TÜV Rheinland. Which tests are more critical for module reliability and quality?
Yes, so I assume you mean for particularly for large size modules, right? So generally tests which relate with thermomechanical stresses have a higher, are more critical. So here I'm talking about things which address bypass diodes, thermal cycling, mechanical load, reverse current overload. These are the most critical tests which I could imagine. And of course, thermal cycling as well.
Thank you, Dr. Christos. Well, that's all the time we have for Q&A. I would like to thank you again for your participation. With the arrival of the grid parity era, the industry has recognized the benefits of deploying high power modules in large sizes for their ability to reduce the LCOE. More importantly, increasing installed capacity has the extremely positive consequence of driving down the price and thereby making renewable energy sources more attractive. Falling energy prices also mean that the real income of people rises. Investments to scale up energy production with cheap electric power from renewable sources are therefore not only an opportunity to reduce emissions, but also to achieve more economic growth. Well, that's all the time we have for today. Once again, I'd like to thank the audience, our presenters, and JA Solar for making this webinar possible. We wish success for your business operations, but more importantly, we wish good health for you and your families during these difficult times. So goodbye.